reaction time, all you're gonna do is take your stick, okay, other person. You're gonna hold your hand out like you're holding the stick, but your assistant is going to hold the stick so that the bottom of the stick is flush with the top of your hand, okay? You should not be able to grab it with your hand. You should just be at the top there, okay? Not inside your hand, not flush with the bottom, flush with the top. And all they're gonna do, you're gonna keep your hand open like this so that the stick can fall through. So while it's open, they're just gonna drop the stick and you're gonna catch it, okay? That's it. Sorry, that's all they're gonna do. Do not count down, okay? Do not have the other person go 3, 2, 1, go, okay? Don't do that. This is about you reacting to them dropping the stick and you catching it, okay? When you catch it, boom, drop, catch, okay? Where the top edge of your hand is that you caught the stick, make a mark, okay? So I will, instead of writing on my wooden stick, I will take a piece of tape and I will just make it flush with the top there, okay? It doesn't have to go on super tight or anything. So if you think about it, this distance is the distance that the stick fell, right? From the time that it was dropped to there. So you need to measure this distance. So for me, this distance, using my now broken thing, there we go. So this was about 13 centimeters, okay? So it fell 0.13 meters. You are going to, okay? You are going to record this right here, 0.13 meters in trial number 1, okay? Take the tape off, do it again, okay? You're gonna do that 10 times, okay? Get an average, so 10 times, blah, 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 add them up, take the average right here, okay? Then, using your beautiful kinematics calculations, you are going to calculate your reaction time, okay? This is just a free fall question. You're starting from rest, you're dropping it with an acceleration of negative 9.1. You know how far it goes because that's what you've measured, so you can rearrange and solve this for time, okay? That's your reaction time. When you solve this with your reaction time, I want you to answer in milliseconds, okay? So what that means is if you, let's say you get a time of 0.321, I want you to keep 3 decimal places, okay? And this time of 0.321 seconds is actually 321, oops, not meters per second, milliseconds, okay? So I want you to answer in milliseconds. Keep 3 decimals so that we can compare our answers afterwards, okay? And then answer this question, write it out. So once you've done that, okay, so you show your you have your data there, show your calculation right here, answer the question, take a picture of that. You are going to submit this in the assignment box on Nexus, okay? And then under communication on Nexus, there is a reaction time survey. I think it's a multiple choice one that I made. I want you to select where your reaction time falls in. So there's different categories from like 150 to 200, 200 to 220, 220 to 240 milliseconds, blah, blah, blah. You'll see. I just want you to select where your reaction time falls, okay? One little thing about this, don't find your reaction time for each trial, okay? Do the average distance fall, your average distance dropped, and just find your reaction time once using your average value, okay? That's a ton of work if you're gonna plug and chug 10 values and then take the average of that. Just find the average of your distance, then use the distance in there, okay? That's your reaction time lab. The instructions are here. I tell you what to do. All that. Biggest things here, do not do it yourself because you know when you're dropping the stick, right? I know when I drop it, so I can just do this. No, that's not going to work. Get somebody else, get them to just change it up, get them to distract you, and then they just drop it randomly and you have to catch it. The other thing, which just when I was practicing this, don't get something too thick because you want it to be able to go through your hand smoothly. If you get something too thick, like, one second, I wanted to use this broom because I thought everybody's gonna have a broom. So this is a broom. This broom handle is slightly is a lot thicker than the wooden spoon. So when it falls through my hand, it actually gets caught on my hand and rubs a little bit, which slows it down. So don't try to use something a little bit skinnier. A pencil is going to be too short, probably. You want something about this distance. Okay, you want something about this length, like 20 centimeters or so. Okay. Any questions about the reaction time lab? No? Okay. Just from looking it up on the internet, it seems as though 200 milliseconds is that threshold of people being like superhuman aliens. So if you're getting a reaction time of like 200 milliseconds or less, like 0.1 second or something like that, chances are you're cheating or your data is a little bit skewed. Okay. Make sure this is completely random. You're completely caught off guard when the thing falls and you're trying to, and you just have to react and squeeze and catch. And as soon as you squeeze and catch it, make a mark. Don't squeeze it and then like slowly walk your hand up a little bit to cheat. No, squeeze it, hold it, make your mark and measure. Okay. Protect the castle. This one is a lot more involved. There's a lot more steps. I am going to give you I'm not going to read each step word for word. You can refer back to it. I'm going to give you a brief overview of what this looks like. Okay. So what you need, a castle or something you want to protect. You don't actually need that. That's fine. But you do need a table. Okay. So you need some type of not a big table, but you need a table. Okay. You also need an army. Okay. This army is trying to siege your castle. So you need to protect from it. If you use literally anything, a stuffed animal, a Lego guy, a G.I. Joe army person, literally anything. I'm using one of Hobbes's squeaky ducks. Okay, it's literally anything you want. If you want, you could cut out a circle and make a little target out of paper, but just use something that you're trying to hit. It's more fun. Okay. Then you need some type of marble, golf ball, tennis ball, any type of ball. I'm using a tennis ball. Okay. If you have a dog or a pet, you can use any of their balls and then you just think that you're playing with them. But just be careful, you want it to roll smoothly. So a ball like this, Hobbes has a nice snowball. This is great. It's pretty much the same size as a tennis ball, but it's bumpy, right? It doesn't roll smooth. So you want something that rolls nice and smooth. Okay. Then you need something to make a short ramp with. This could be cardboard. This could be books. If you have a piece of wood, would work. This right here, I have a piece of wood. There's my ramp. Okay. It's 44 centimeters long. Great. I propped it up with some books and there we go. Okay. The ramp doesn't have to be anything fancy, but you don't want it to sag in the middle, right? If you use a piece of paper and you try to roll a ball down a piece of paper, it's gonna sag, right? You just need to make some type of nice, smooth ramp. You also don't want that big of a lip between the ramp and the table, because you want the ball to roll nicely onto the table and not roll onto the table and start bouncing like crazy. Okay? So nice ramp, beautiful, support it up. You can make it as steep as you want. Okay, this is like maybe a 20-degree angle or so right here. The steeper it is, the faster your ball is going to go, and that's going to change something from the next part. So you might just want to play around with it. Okay, you'll need some type of measuring stick before, ruler, tape measure, whatever it is. If you use a tape measure, a lot of times, most tape measures, mine has centimeters, but they're in inches. So if you use inches, that's totally fine, but just make sure you convert them to meters. Okay, you can't use inches in calculations. Need pencil or tape again, or both. A timer, your stopwatch on your phone is just fine, or someone else's phone. And then a phone to record a video, because I want to see you do this. Okay, but I'll show you that. I'll tell you that in a second. So what you're going to do, okay, all the materials make sense. That's all the stuff you need. If you think you have any issues trying to get any of that stuff, please let me know, but you should be able to do this with what you have at home. I bet you that you could do this exact same experiment with a cookie sheet. I could put this cookie sheet and make a ramp out of a baking sheet. Okay, it's really, really, literally anything. Okay, so what you're going to do, you want to set the ramp up so that the end of the ramp is about 80 centimeters or so from the edge of the table. Okay, you want it long enough that the ball rolls nicely across the table, but not super long that the ball starts to slow down. Okay, so what I mean by that is, because what you're going to do is you are going to time how long it takes the ball to roll from the edge of the ramp to the edge of the table. Okay, so if you have a super short ramp, or if you have a ramp that, say, goes from here to the edge of the table, this distance is super small and your reaction time is going to come into play. If you have a super steep ramp and the ball goes really, really quickly, you probably want to use a longer ramp or a longer distance. I found this one that I'm using is 83 centimeters. So if you watch, let's see, this is really fun. Okay, so if you watch the ball roll down, see, it's nice. It's a nice smooth motion, not too fast, not too slow. It doesn't slow down at all. It's a nice smooth motion. Okay, and I used 83 centimeters from the edge of the ramp to the edge of the table. Okay. So you are going to measure that and record that distance as D1 in the data table. Okay, that's your table distance, not including the ramp, has nothing to do with the ramp. It's the flat distance of the table to the edge of the ramp, edge of the table. Okay. You need to make a mark on your ramp. It doesn't have to be at the top, because my ramp's short. I did it at the top, where you are going to release the ball from every single time. Okay, it doesn't have to be anything fancy. You just need to know that you're going to release the ball from that exact spot every single time. Okay, you are going to release the ball and then time the ball as it rolls down. Okay, as soon as it hits the table and starts covering your distance, start your timer, and you're going to time it until it reaches the edge of the table. Okay, so don't time, don't time, don't time, don't time. Start the timer, roll, 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 end the timer. Okay, you want that time to be, I don't know, like when I did it, my time was 0.8 seconds. Okay, you want it to be like, you don't want it to be too short, because your reaction time of starting and stopping the timer is way too quick. so just kind of balance your ramp and your distances and stuff so that it's a nice long time, like 0.8 seconds, 1 second even would be good. Okay. I'll write that on this sheet so you can refer to it. Yeah, aim for a time greater than 0.8 seconds. I'll say, come on. I use t equals 0.8 seconds. And that worked well. Okay. You're going to do that 5 times, record it, take the average. Cool? Cool. That's step 1. Okay. Then you're going to calculate the horizontal speed. So I outline that under calculations, the speed calculation. You use your average time. Okay. You have your distance that it's moving, and then you're going to calculate your speed and you record it as Vx. This is just, there's no acceleration, right? Because we're assuming this ball does not slow down on the table at all. So it's a constant speed, moving the distance, DTV, literally just divide the distance by the time. That's all it is. Okay, there's nothing fancy with that calculation. But now, you've now calculated how fast this ball moves across the table, okay? And how fast that ball is traveling once it reaches and once it's falling off the table, okay? With me so far? Any questions? We're good? Cool. So, next, we need to measure the height of the table. So, again, just take your measuring stick, okay? Measure the height of the table from the edge of the table, top of the table, down to the ground, nothing fancy. I would suggest taking a longer stick, like this broom or something, and making a mark, like holding the broom straight down at the edge of the table to make a mark on the floor where exactly the edge of the table lines up on your floor, because you don't want to be measuring from like back here or like way out here. You want to make sure that this is nice here. Okay, so you're measuring this height of the table, and you're gonna record that as height. Okay, but now you need to calculate the horizontal distance that your ball is going to travel. Okay, and to do that, I outline the steps here for the range calculation. We can treat this question as a free fall question. Yes, the ball is moving horizontally, and then it starts to drop as it leaves the table, but that horizontal speed has nothing to do with the vertical direction. We can assume that as soon as this leaves the table, this ball is going to continue moving forward at whatever your horizontal speed is. It's in the vertical direction, it's going to start at 0, your VIY, your initial velocity in the y direction is 0, and then it's going to start dropping. And all it's going to do is it's going to drop a distance of the height of the table that you measured. So all we're going to see here, right, it's going to see a change in height is equal to 1/2 AT squared. The acceleration being gravity, negative 9.81. So you can use that formula, calculate your time. That's how long the ball is in the air for, from it leaves the table and down. We can use this time, right, while the ball is falling. The ball is also moving forward with our horizontal velocity. Yes, there's air resistance and stuff, but we're not going to deal with that. So however long it takes the ball to go from here to the ground, well, at the same time, it's going to go from here a distance here and it hits the ground. So you can use that time with your horizontal speed, calculate using your DTV to calculate the range to see how far horizontally this thing's going to go. Okay, then you're going to record that under R, under the range. Okay, That's your distance. That's the magic number. This right here is the magic number. Magic number. Okay? Because what you want and what you're going to do is take that and you're going to measure out the distance. For me, when I calculated it, I got 0.41 meters. So welcome to my floor. It's probably dirty and covered in dog hair. So what we're going to do is you're going to measure out from the bottom of, from like the edge of the table on the floor, measure out. For me, I calculated it to be 41 centimeters. So that's a mark right here. I'm going to take my army. I'm going to put my army right there. And now we siege the castle, or sorry, now we protect the castle. Take your ball. Let's see what happens. Go to your starting point. Do you think I'm going to hit it? Maybe. Let's see. Okay, wait, I want to make sure I can get all of this. This is really difficult to do. Okay, here we go. Oh, I don't know if you saw it. I missed a little bit. I try it again. Oh, just hit his beak. Close enough. A main source of error with this is since this ball is traveling quite a distance on the table, it's going to go back and forth, right? Which means lining up the path of the ball with where it's going to hit on the floor is really important. So make sure this army person here, make sure you kind of line up. You want it to be in line, right? Imagine a straight line coming down your ramp, off your table and down. That's where you want your army person to go. So let's try it one more time. It's going to work. It's going to happen. Here we go. Oh, I missed again. That's okay. That is okay. But that's the idea. You should, if you do everything a lot more careful than I did and you're not holding your computer while doing it, you should smoke that army person, okay? You should. And if you don't, check your like if you're close, if you're super close, just adjust the path of your ball as you're dropping it because it will wiggle quite a bit. If you want to get fancy and try to add like a track for the ball to follow across the table, you could do that. If you're way off, like if you're way short, go back and double check your calculations because you should get, like it should be right there. You should be able to smoke it pretty much exactly. And that's what I want you to record a video of. So you might need some help here. I want you to just use your phone, take a 5-second video of the ball rolling across the table, like rolling down the ramp across the table and hitting your person. Okay, if it doesn't hit, that's okay, but at least I can see you close. Okay, because I want to see that you actually, I want to see your setup. I want you to see it. I want you to see that you built it and whatnot. Okay. The data table. Oh, and then, okay, so once you do it, I want you to get a couple different sized balls and try it again. Like once you've set everything up, you've recorded, before you take it out, try like different sized balls, a smaller one, maybe get a heavier one. Just see if it still works. Okay. It should, but just try it. Okay. As long as the ball is not bumpy and weird and it still rolls nice, it should still work, but try it, see what happens. Okay. Your data table. So this is the first part. This is your measured distance on the table. So this is the table distance. This is your calculated table velocity, right? This is your table time. This does not include the ramp, not include the ramp, okay? then you show your calculation right there. Next part, right? Measure the height of the table right here. This is the table. Table height right there. And then you're going to calculate the time. Okay. That is not your table time. Nothing to do with your table time. Okay. This is important, right? Gravity is negative 9.81 and your initial velocity in the y direction is 0. So very, very important. Okay. Show your calculation right here. We're happy about it. And then calculate your range, right? This uses Vx and your time right there. Okay. Calculate your range, show that calculation right there. Okay. And this is what, right? This value is the value that you measure and mark on the floor. That's how far you put your person. Okay. So you are taking a picture of this data sheet page and submitting it in the assignment Dropbox on Nexus. Okay, you'll see it's there. There's also 3 questions that I want you to ask. Did you hit? Talk about error, some issues that you had. Why can we assume 0 acceleration in the x direction? Okay, and did you try it with different size walls? Did it work? And just how that went. These 3 questions, I want you to type. Okay, I'll do it a little bit. I want you to type on Nexus in the assignment box. Okay, so when you submit your assignment, you should be able to add a little note to it. I want you to answer those 3 questions there typed up, because the chances of me being able to read your writing as you guys write this out and take a picture of it, very slim. So just type it out in there, submit it there, and then I can add the mark to it. Okay, that's for all of these, by the way. Okay, so to calculate the range, this is just using DTVX, okay? Where this time is the time it takes to fall to the ground, okay? Your VX was what you found. Your VX was the horizontal speed that you found the very first thing by timing this distance and measuring and calculating the speed. Okay, so you're using that table distance speed, the horizontal speed, and then the time it takes to fall up and down. Okay, you can, if you want to type this up in a Word file, absolutely. If you want, to kind of recreate and recreate, I guess you can see this, the data table and whatnot in Word. I don't need any of this stuff, right? All I need is to see your data, your calculations, and all that stuff. By all means, do it in Word, but please submit as a PDF. Okay, if you submit it as a docx file, it just blows up. I don't like it. So please submit everything as a PDF. Okay. And the 2 labs I think Monday's pretty reasonable if you can get them done over the weekend. The first one shouldn't take you more than half an hour to do. This one might take you an hour to do. So yeah, you should be able to get these done by Monday. Okay, I can be a little bit lenient Tuesday at the very, very latest, but I think there should be no problem for you to get this done by Monday. Okay. Any other questions? Anything? One little note I'll add here. My guess that this, oh, stop it. There we go. this speed right here will probably, let's say it should be around 1 meters per second. Okay. If it's like 0 0.8, 1.4, that's fine. But if you're getting like 0.02 or like 5 meters per second, chances are you probably did it wrong. Okay. So you should be aiming for it to be around 1 meter per second. Table height is going to vary based on your table. Mine was 75 centimeters tall. Yours is probably going to be similar unless you've got a giant table. The time of flight should be approximately, when I did it, I think I said my time of flight was approximately 0.4 seconds. I would suggest keeping 2 decimal places with this. So I think mine was at 0.41 seconds. Just to give you an idea, again, a little bit less, a little bit more is fine, but if you're getting a time of like 1 second, that's probably not right. So you want to go back and check it. And your range, my range was my time, mine was all pretty much exactly the same. My time was 0.39 seconds and my range was 0.41 meters. Okay. Again, you're not going to get the exact same numbers, but if you're getting a range of like 5 meters, you probably did it wrong. Because think about it, right? This ball is not going to roll off the table and land 5 meters away unless you're shooting it with a jet, like with an air cannon or something. It's not going to happen. And here's the thing, don't just cheat, okay? Because I need to see your work anyways. Don't just cheat by saying, okay, watch the ball roll off the table and say, okay, it landed right there. So I'm going to put it landed right there. So I'm going to put my person there so that when I roll the ball off the table, it hits it. Okay. Don't just do that. Actually go through the calculations, and you should, I'm proving you physics works. This stuff is real life. I'm not making this stuff up.